Thank you very much, everyone, for being here. This is Embodied AI, Invisible Cues, and we're going to have a 45-minute panel discussion with around 10 to 15 minutes of audience Q&A. So if you do have any questions, we've disabled the chat. We'd really like you to use the Q&A tool in your panel at the bottom. Okay, this webinar is also being recorded for YouTube and LinkedIn, and all your cameras and microphones are disabled. So welcome to the first webinar. It's actually going to be in a series of Embodied AI, which is explaining and exploring how AI systems sense, reason and act in the world, and really what that means for human trust and understanding. And this idea came about from seeing how much discussion there's been about AI in AVs, but the real focus is on engineering performance and a lot less on how these systems actually communicate, both with passengers inside and with pedestrians and other road users. So under the AV Act 2025, the UK government has promised that AVs will be on the road by 2026, with implementation programmes already underway to achieve this. And the ambition is also embedded in the Transport AI Action Plan, which is setting out how AI will be responsibly deployed across the transport system to deliver safer, cleaner and more inclusive mobility. So many of us at this webinar, and certainly on the panel, know that different kinds of AV services rely on different types of AI models. But to the public, those distinctions aren't going to mean very much at all. People will judge AVs by how understandable, how predictable, and how inclusive they feel in practice. But that means that people might expect to understand why a vehicle is doing something or to have some means of control if they disagree. And for different users like disabled passengers or older adults, children, the level and the mode of communication needed can vary hugely. And if systems aren't intuitive or inclusive, users may feel confused or excluded, and that's where trust might break down. So this webinar brought together experts from industry, academia, software development and manufacturing to explore some of the key questions about AI-human interaction and how users are really going to engage with AI. So we've brought together this panel today, and I'm going to tell you a little bit about their backgrounds to try to bring to life what they're bringing to this discussion. So representing users' lived experience of transport and travel and the charity sector, we've got Rebecca Posner. She's Director of Research at the Research Institute for Disabled Consumers. She combines behavioural psychology with innovative research methods, and she led the UK government's programme on social and human factors research and behavioural change in self-driving vehicles. So we'll be drawing on Beck's expertise in understanding and diversifying the users we engage with in AV services. And then we've asked people from the academic world. So we have Professor Natasha Mirat, OBE, who leads the Human Factors and Safety Research Group at ITS Leeds. And she's also Academic Director of Virtuo City, which is home to the UK's most advanced suite of pedestrian and driving simulators. So her main goal and her focus on this panel is to really help us understand how road users and pedestrians communicate and understand implicit signals from AVs. Also from academia, we have Professor Ignacio Alvarez, who's Professor of Human-Centered Intelligence Systems at the Ingolstadt University of Applied Sciences. There's not really much that he hasn't been involved in many areas of intelligent mobility over the last sort of 20 years. His voice spans voice-based assistance systems, automated driving technologies, and more than 150 patent applications. So he's bringing an international perspective on embodied AI and some real-world examples of how we're figuring out cross-cultural adoption and validation mechanisms. Then we have Jim Hutchinson, who joins us from Fusion Processing. He's coming from the software development side. So he co-founded Fusion Processing in 2012 and developed the CavStar product, which is a complete automated drive system that can be fitted to any vehicle to enable level 4 and level 5 autonomy, and has already successfully deployed on a number of different sized buses, minibuses and vans, including tractors and single seat cars. So he's going to share his perspective on AI software and hardware development, as well as that vehicle safety and human machine interfacing. And finally, we've invited two automated vehicle technology developers and operators to give a balanced view of how embodied AI is being designed, tested, and actually deployed in the real world. So Dr. Trent Victor is Director of Safety Research and Best Practices at Waymo, an AV operator and technology developer which is focused on safe deployment. So Trent represents safety issues within Waymo and coordinates the development of best practice both internally and across industry standards. And he's committed to developing sound measurement methodologies, so that measuring the safety impact very carefully. So he's going to share some on-the-ground learning from Waymo. And finally, we have Daniel Quirk, who's Senior Public Policy Manager at Wayve, a London-based company pioneering embodied AI software so that vehicles can have safe driving intelligence to operate anywhere. And he works with policy partners around the world on the future regulatory framework for AVs. And so he will be bringing both a technical and a policy perspective, including direct feedback on Wave's work with government on the development of the AV Act and secondary legislation. So welcome to our panel. Thank you so much. It's a really exciting group of different types of, developers and charity organisations and academia. So we really get the benefit from everybody's shared experience. I'm going to hand over to Saber we should also introduce ourselves. So I'm Dr. Claire Metzenik. I am founder of Anthrometric, and I'm joined by Professor Saber Fowler from the University of Surrey, and we will be co-hosting this event together. So Saber, over to you for the first section of questions.
Okay, sure. Claire, let's start with the technical questions from our industry panelists. We have heard in the back a lot about the use of LiDAR and camera and how this differentiate in terms of the safety, which one is better. There are a lot of discussions. But when we come to AI architecture, the question is different. The common question is that what is the difference between end-to-end and modular AI systems? Or recently we have some sort of the hybrid AI that combine both modular and end-to-end architectures. I would like to ask, start with Daniel from Wayve. As I know that they use the end-to-end heavily for their product. How these systems differs, and what is the choice for choosing end-to-end or modular AI architectures for driving cars?
Thanks, Saber. Hi, everyone. Nice to be here. So yeah, as Claire introduced, so I work for Wayve. We're a UK-based company that's very much focused on building the AI software that will be used to power a range of driving assistance and automation features. But we would always partner with a car manufacturer to integrate that software into their vehicle. For us, end-to-end AI has been a really important part of our identity. I mean, Wayve was founded in 2017. Off the back end of our CEO and co-founder Alex Kendall's PhD in computer vision, and he was very much of the view back in 2017 that to look at the self-driving problem, we need to look at decision making and seeing machine learning and the advances that were happening in that field as an opportunity to rethink how we look at the self-driving problem. So Wayve ultimately chose end-to-end because from our perspective, we're trying to solve the self-driving problem from a scaling perspective. So how do you make these systems scalable and accessible to everyone everywhere? The main distinctions between an end-to-end approach and where the industry traditionally has been is that our solution is mapless, and also it requires little to no previous data to be able to move and adapt to new areas. So from a scalability perspective and bringing this technology to new markets, it presents a real opportunity to develop a really adaptable software solution that can be integrated into any type of base vehicle and deployed around the world.
Excellent. Thank you very much, Daniel. And it's good to hear from Jim as well. Jim, from your side, what is your opinion on that?
Yeah, so there's lots of different approaches to these things. I don't necessarily want to go into too much detail on architectures, but I think the key thing is that anything we do must be safe. Safety comes first on all of these things. And so really, in some ways, the AI is secondary. Really, is the first consideration has to be, how do you engineer this to be a safe system? And so within that, in our world, certainly being able to explain why a system made a certain decision or did a certain thing is absolutely key. So whatever architecture you may implement in your system has to be able to do those things. That's probably the main contribution I can make to that one.
Yeah, absolutely. I totally agree with you. You touched a very important point about the safety, how we can make sure that this architecture are the safe way or can perform in the safe way. This is come to the questions of the regulatory perspective. Do you think we know that one of the barriers at the moment challenges for the deployment of the self-driving car, especially in the UK, is the regulatory matters of these cars? How to regulators can make these products certify them, in fact. So what do you think? Do you think the choice of architecture has a huge impact on regulatory aspects, or can make regulatory challenging for the regulators?
So I think it's important that any regulation doesn't assume a particular architecture. I think the regulation and the requirements in order to get a vehicle certified for road use should not assume any particular architecture. That's really, really important.
Oh, that's interesting one. Is it easy to make that regulations applicable to all architectures? Is it straight? And I would like to know that how much challenging would it be to have, or what approach the regulators need to take to make it applicable to any architecture, regardless they are end-to-end or hybrid or modular. Now, I leave to any of panelists, Trent or Daniel or Jim, to answer it.
I can come in a little bit here. I mean,
Yeah.
So at Wave, we spend a huge amount of time working on the emerging regulatory framework. And I think it's also really important to remember that certainly in Europe and the UK, where we're in type approval markets, so it's a different way of thinking about how these systems are brought to market compared to maybe North America, where it's self-certified. But there's been years of work on the technical framework to start to develop the regulations for this. So at the UNECE, where global vehicle regulations are set, since about 2017, we've been working on the framework for level 3, level 4 systems, and that actually is due to come into effect next year. And to Jim's point, it's absolutely key that we should be building smart, kind of future-focused regulation that isn't about a particular technology and is agnostic, because the reality is where the technology is today versus even a year ago, let alone 5 years ago, is very different. And end-to-end in the context of this conversation, right, is one example of that evolution of how architectures and advances in AI are going to be used by different developers in different ways to bring more performant, adaptable, safe systems to the market. So the regulatory framework has to be outcome focused, and it has to give the space to manufacturers to present their evidence to regulators as to why their systems are safe for a particular deployment. And that's exactly what has been happening at the UN. And then if you think about it at a national level, it's one thing having your vehicle approved at a technical level, but you need the right to deploy. So you also need a legal framework, which is what we've been seeing with the AV bill. And what we want to see in the UK, for instance, is that mirroring of the technical requirements of the UN being implemented at a national level, so that regulators, have that kind of global standard they're working to. But also it means manufacturers who are building for scale here, right? Like no one is producing a fleet of vehicles for a very small deployment. They have the scale to be able to bring production vehicles through the market that can be deployed globally. So it's really key that we've got that future looking aspect to how we're developing the regs. And I'm pleased to say that I think where we're at with the UN is we're getting something that's going to be future-proof for the industry to deploy.
Oh, that's great. Great to know these things. Thanks, Daniel. So this brings to my mind the role of the explainability of AI. How do you think that explainable AI can help to advance or make the process of the safety regulations faster? What is your opinion, Daniel, on it? How this AI should be explained? What is the concept of the explainability for AI, and what is its role for speeding up the regulation process?
So again, I think we throw around the term explainability in a way that sometimes isn't helpful. Explainability can mean many different things to different people. I also think at times it can be a bit of a red herring. I mean, what we've got to focus on, and what the regulatory framework focuses on, is giving manufacturers the space to be able to present the evidence for why their system will meet the expectations they're setting, and it's reliable to a standard that can be accepted, in public deployment. What also matters is we as manufacturers have to be able to work with a regulator to help them understand and see how the system works. And if there is an incident or if there's a problem, we need to be able to identify that and remedy that. Now, whatever architecture you're working to, that core principle is really key. And actually, through a lot of the in-service monitoring and reporting and data storage requirements that are on manufacturers through the framework, there is the basis to provide that ability to introspect and to interrogate and investigate why things have gone wrong. Ultimately, the regulator needs to be confident that whatever a manufacturer putting to the road is safe to the level it's been validated against, and that if something does happen in use, it can very and easily be identified and addressed. So for me, the explainability piece is about those principles, not just explainability for any purpose.
Okay, that's a great point. You raised a very important point about the sharing of the data with these regulatory things. I'll come back to that questions later, but I would like to Trent comment on it. He raised his hands. Go ahead, Trent, please.
So I just wanted to say that we're expanding, and part of the expansion is to come to London, and that's we're really excited about that. But also part of that expansion is the regulation that's associated with expanding to London. So the previous speakers have talked about that, and maybe what I could give is a little more color on the work that we've been doing to make it understandable. So the papers that we've been writing, I have a strong belief in like taking a rigorous approach where we've spent 48 papers to try to explain our approach to safety, and what we're met with is that it is complex, and the regulation itself is complex. So this is a complex topic to show safety on so many different topics, right? So what we need is to enable a discussion, and that is based off of evidence and claims that are presented in an orderly fashion with the safety case. And that's what's so exciting about this new regulation, is that it's actually structured in a way that allows us to present our evidence, and that is quite different from there being a notion of simplicity that maybe the general public would have.
Yeah, perfect. Yeah, thank you very much, Trent. So I would like to hand over to Claire to ask some questions about user experience and the human and AV interaction, and we will come back to the concept of the safety again after Claire questions. Yeah, go ahead, Claire, please.
Thank you. So this section really is about how it communicates. So we'll sort of keep the focus with Trent for a moment about how does in a Waymo vehicle, how does it communicate its intent, both to the passengers inside the vehicle and then that sort of interaction with pedestrians and road users outside it. And then we'll come to Natasha and Bex to sort of lend that human factors and inclusivity lens to it, to understanding from the user's perspective as well. So Trent, if you can just sort of comment on that for what Waymo's doing at the moment.
So we have hundreds of thousands of trips each week. We're expanding very fast, and so there's been a development loop with users involved. So this is pedestrians around the vehicles, or it's people in the vehicles, it's people using the product, and as like any product development, you have continuous refinement. So this the user experience, how to understand how to open doors, how to when you're pulling over, all these different factors have been intensely studied and developed with the product, right? So I think that we're seeing a lot of joy and people that are loving the product, and that really makes me proud.
Yeah, and can you tell us a little bit, sort of in a practical sense, maybe about one of those refinements, maybe as you've been doing all of this trialing, what's that feedback loop been like with users or pedestrians, and what changes might you have put in place in response to that?
So pedestrian safety is extremely important for us. Like we're in dense urban. This is where pedestrians and our VRUs, vulnerable road users, it's cyclists as well. So getting cyclist organizations that are really positive towards the behavior and they feel safer around the Waymo, that's a really a good evidence of our work, right? And but also that we just recently shown a breakdown of different types of crash types, and with pedestrians we have a reduction of the largest reduction of 93% reduction of so we have been extremely attentive to, the behaviors, so and that's like a lot of different things, right? So I think it's mostly around like how you balance the behavior. Right? So it really does come down to like your interaction in terms of movement rather than like some kind of like a communication by other means.
Okay, and so Natasha, I know the work that you're doing at Leeds is really focused on that sort of communication and different channels of communication between the sort of the AVs and pedestrians in particular. Can you tell us about some of the findings? Like, what's the most promising channel? Is it visual, auditory, and motion cues, like Trent's talking about?
I would say it's not as simple as that, sorry. So just to give you an overview, so the work that I did on these kind of like level 4 or without a driver type vehicle was back in 2016, where we were looking at the pod-like vehicles, which were part of the European project City Mobile 2. And we were trying to understand what do pedestrians need from these vehicles in order to be able to interact with them safely on the road. And then over what is nearly now 10 years, actually started in 2012, so it's over 10 years. What we've been looking at is, first of all, external communication, and there is an interest in that from various OEMs, and there's some ISO documents of colleagues online who have been very active in that area. And the general feeling now is that we, even though we don't necessarily believe it, but we don't tend to use explicit communication as pedestrians and drivers. So we don't actually, less than 10% of our communication is with our hands and our heads and our eye movements, even though I'm using my hands a lot. So actually, what we tend to use is what we call implicit information. So we can tell as human beings very well if the vehicle is going to stop or not, and if it's yielding for us or not, and also using the lateral movement of the vehicle. So that's one of the things I guess that would be really nice to see, is how this kind of more human-like implicit communication can be shown, because that's something we understand as pedestrians right now on the road. Of course, explicit communication, some kind of light to say, I'm about to stop or whatever, has been used, but that's really mostly around what I call standoff situations. So the very famous one back in 2012 was the Google car, as it was called then, and the cyclist coming to a stop sign, a kind of four-way road, and both just stopping, because they couldn't kind of communicate with each other. And in that situation, it is nice. And I think that basically at that time they had the safety drivers in, and the safety driver went like that, go on to the cyclist. So we do need that kind of information for specific environments where there is maybe a sort of jaywalking or whatever, which of course London, oh my goodness, is full of them. So really challenging to be able to achieve that. So I'm just going to stop now because I could go on for the next 40 minutes.
Of course, thank
but I
you.
won't.
Well,
I'll just talk about the other stuff in a bit if you give me
in
a
a
chance.
moment, yeah, because I'm hearing that, and it's so interesting, like you say, that there are assumptions perhaps as to what we'd prefer, but that a lot of it is implicit. But that defaults to a certain type of pedestrian or a different type of user. And I'm interested to bring Bex in, that in terms of, how do we make these signals accessible for all people who might have different sensory or cognitive needs, and really even within that community, what are the risks of sort of homogenizing a disabled user as one thing and being able to deliver for them? And perhaps if you want to give us your perspective on that, Bex.
Yeah, absolutely. I think I'm probably going to be agreeing a lot with Natasha today, which is I think everyone does generally. But I think the key thing to remember here is if we look at existing vehicle behavior, very rarely is there a vehicle that suddenly says stop at the front. That there is never a driver in a vehicle that will say stop to other road users. And I think the issue we've often had when we look at vehicle to other road user interaction in particular is this assumption that we need to create signals that weren't there beforehand to try and overcompensate for something. And I think that's probably an inaccurate place to start from, because exactly as Natasha said, that's not currently how people behave, but also it is expecting that there's one solution fits all. And regardless of if we go down the route of EHMI, at some point there's going to have to be a standardization. That I think everyone can agree on that, which is there can't be different mechanisms, different avenues, different signal types, different colors, because that is going to create an even more complex environment, which, as research has already shown, where you start losing those different aspects, it increases uncertainty, it increases cognitive load for other road users around it, and the consequences on other road user behaviors are generally negative, increased hesitation, and all those different aspects, which then have an impact over how the vehicle would react and behave in that space. When we look at, and then the point I'll make in terms of the HMI and the example is, if you are an individual with a visual impairment, having a visual cue on a vehicle that informs you of the behavior completely misses the point. But equally, if you use an audio signal, which is one of the other things that's been considered, if you have a hearing impairment, it's something that won't work with you. But more importantly, if you are someone with sensory sensitivities, for instance, someone who is neurodivergent, someone with cognitive impairments, you will also likely to become overwhelmed. Your behavior then changes, and the predictability and what the system has been educated and learned on, regardless of the architecture, then varies, and you kind of end up in those situations of unpredictability. So the reality is that, exactly as Natasha said, there's no simple answer to it, which is part of the problem. But what we do know is that regardless of which route we go down, looking at existing patterns of behavior and making sure that when we are engaging with what we deem by existing patterns of behavior, we are looking at and engaging with a group of individuals that are as diverse as the current group of road users today. If not, and if I may, even more so, because one of the key aspects that we've always said about automation and AVs is that they will improve the accessibility of transport, which means by that, it means that there's going to be a greater diverse group of users interacting and engaging with these vehicles, or that's the outcome we are intending to. If at this stage of determining how we are training the systems, we are not engaging with, we are using the same groups that we are currently using our transport systems, we are just perpetuating existing behaviors and not enabling us to achieve those kind of target goals.
Yeah, so true. And as both you and Natasha are saying, it is complex. Let's add an extra layer of complexity by bringing Ignacio in to tell us about the impact of culture. And just as Daniel was saying, we need to have something that is regulated at different international level. Ignacio, I think a lot of your research has been looking specifically at that element of, like, can you standardize across different cultures? Can you tell us a little bit about the complexities there?
Yeah, it's actually been a very, very exciting last years, and I can tell that it's a really exciting future that we have ahead of us. Because we found in the technology, we found these amazing algorithms that can process this super complex data, but can also generalize fairly good and make useful predictions. And so what that is driving is essentially AI boosting the adoption and the generalization of the driving in different scenarios, like Trent was saying. Waymo is expanding, Daniel as well. Waye has been expanding very rapidly. And so what that brings is embodied AI that is very rapidly being deployed in different contexts. And this is possible because these algorithms are able to learn. And if you think about it, we as humans are able to drive, but we all know that it's not the same driving in the German Autobahn that it is to drive in India, traffic. It is not the same to try to drive in the middle of Ecuador mountains that it is to try to drive in London. And so there is cultural differences, and those cultural differences are becoming very interesting. So one example that I can tell about is when we were developing computer vision algorithms to be able to detect road users, to be able to detect vehicles, pedestrians, and others. We thought that we had built a very good and reliable and robust platform. And the moment that we started testing those algorithms in areas that were a little bit out of what we had originally intended, went to rural areas in India, for example, we're not getting the performance that we were expecting. And that forced us to really understand that there has to be this continuous process of learning and adoption, and at the same time, really looking hard at what generalization capabilities we can building redundancy in our systems itself. And I think we are at a very unique point in time right now, where we're seeing a sort of a very rapid development in different parts of the world, and we have what has been traditionally Western-based AI systems being deployed in non-Western areas, trying to cope up with the challenges of the differences. But at the same time, we're having very rapid growth of for example, Asian-based AIs that are now being deployed in different parts of the world. And eventually all of these make it to the global south, which also shows different challenges and understanding. So I think this complexity really comes into place when we're looking at how do we bring embodied AI to these different contexts where the existence of these cues is not the same, and how do we do it, bringing up explainability across the board, and explainability is actually a very exciting and interesting point, and I see a lot of hands up in there, so I'll definitely let them comment. I just want to say one more thing, is that on par with this capability of these learning systems is we're bringing reasoning into these AI systems. And reasoning is an amazing feature that we're starting to discover, because it empowers this knowledge of explainable AI. The AI is able to explain to you sort of what are the mechanisms that are guiding its decision making. The challenge of doing that is like, what do we really need to be explained? And that is still a very much of a research question. We're still trying to figure out what is the best mechanism in these dynamic contextual scenarios, what to say, when to say it, when is it important to say it, in what format, and doing it with the purpose of finding a proper, I call it calibrated trust, where people don't over-trust the capabilities of a system that looks like it's able to do a lot of things, and at the same time, they don't understand it and therefore hindering adoption. So that's sort of what my body of research is.
Yeah, it is, whether it's a consistent mental model of AV across different cultures. But I think, Daniel, your hand came up, I think, when he was talking about the different types of Asian cultures. Is it something that you were going to comment on in terms of Wave's position in Japan?
Yeah, so I mean, it reminded me really of the key thesis behind kind of our thinking about embodied AI, which, it's a data-learned approach, right? So you're basically developing AI models that are learning from the real world and behavior in the real world. And actually the ability to then take that model that's been trained in London, on vast data sets, and then planted in somewhere like Tokyo, where, Wave expanded to earlier this year, you can instantly start driving right away, because actually a lot of the common behaviors and competencies that we need to be able to drive in London also translate very nicely into another denser urban area in Tokyo. But of course, there are cultural differences. And again, one of the benefits of using, very targeted data from a new locality you can very quickly start to see that adaptive, intuitive behavior in the driving. So we released a blog actually just yesterday that documented some of the progress we've made, and actually with very small amounts of localized data, so I think 1.3% of Japan data in our data corpus, we were able to see a 2% increase in performance within the first kind of few months of being in Japan. So it's that scale and that speed at which you can start to really benefit from the data learned understanding about a particular place. That means you now have a much more intuitive and adaptable driving system to integrate.
When you say integrate, in terms of sort of the cultural etiquette in different sort of places that you're trying to deploy, I presume as well. Were there many differences that you're seeing as you're coming across to the UK with those learnings from Japan?
Well, so I mean, we're seeing kind of an uplift across performance in all our geos as a result of the Japan data, because again, this is ultimately about generalization, right? So the models generalize their knowledge and understanding across that global baseline model we have. We then curate those models for very particular geographies. So actually, yeah, performance uplift across all geos, US, Germany, and the UK, because the model is learning from all of this global diverse data. What we need are systems that can deal with real world variability and complexity. We don't know what's around the corner, but you need something that has seen something similar before and is able to then generalize and apply it elsewhere. And whether that's in the UK or California or Tokyo, we see a lot of common challenges in scenarios and situations that our systems encounter.
And Trent, your hand was up as well. And I mean, Waymo has obviously got a lot of data and a lot of experience. How can you add to this learning?
Yeah, so I wanted to talk a little bit about that the core here is expectations and understanding expectations. So like value sensitive design and talking to separate user groups like blind. So we were like Royal National Institute of Blind People in the UK, for example. And so what we've introduced is talking about drivership. It's like roadmanship or drivership that represents a body of work of understanding expectations, and so when you're part of the road system, you are in collaboration with others, and then so it is really about interaction, and that's what I was alluding to previously with the developments with pedestrians or cyclists, is that you're trying to meet expectations, but there are also it's also a new technology, so you can think of furtherance expectations or things that are characteristics that are new. And when you're introducing new characteristics, like a vehicle that doesn't have a driver, then you need to understand how to best design that system. And I think that this is what we're trying to get at with research on drivership, and it's a discussion with stakeholders, and it's all about appropriate expectations, so that you don't have a miscalibration with that.
Yeah, and I guess that calibration, and then how do you validate it? Ignacio, have you got a comment for us about that kind of how do you know what metrics or benchmarks matter most when you're trying to validate an AI embodied system?
Yeah, it's very interesting, because what we're sort of facing in the automotive industry is that we're moving from just validating the platforms, the control logic, traditional automotive systems. That's what they really good at. Now we need to validate also the software. We need to validate a data-driven software, which means that you not only have to validate the control logic, the systems running, you need to validate also the knowledge that is embedded on the model. You need to have the ability to measure how the model is making proper use of that knowledge, and you have to evaluate if there is any bias sensitivity that you have introduced with the data on the training. And the reality is that the traditional validation and verification methods that we've been following until now are really not enough, and so we really need to expand and really come up with hybrid approaches. And some of the folks in this panel can talk a lot about it. The beauty of it is this is not a problem that can be solved by a single company. This is an effort that needs to be done as a whole industry together. And so you have automakers, you have tier one suppliers, you have researchers like me, you have government entities. All of us need to come together, because I think the reality is that in order to be able to validate these technologies to the point that can be trusted and accepted globally, we really need to first design for diversity, like Rebecca was saying, validate for local needs, and really let mass adoption be based on these transparency. So we really need these collaborative methods, cross-industry standards, user community input, super important, and field trials everywhere, and then a good assessment across geographies. But yeah, I'll let the others as well comment.
That's quite a list. I think someone will have been furiously scribbling those down. Natasha, let's bring you in. I mean, your experience obviously is in the academic world and doing that rigorous testing. What can you tell us about what you can test and what you really can't?
Yeah, that's a very good question. Well, I think I just want to follow up on Ignacio's suggestion. There's lots and lots of trials. I think as you know, a lot of my work is in a more controlled environment where we do things that are not possible or not safe in the real world. We can continuously repeat the study to really understand that control is really valuable, which you can't have obviously again in the real world. And we can think of things that haven't even happened yet in the real world. And certainly in 2012, when we started looking at this external communication, these vehicles were not on the road, etc. So I think for me, it's an ecosystem of Trent, actually, you may not remember, a long time ago mentioned how this development is kind of like how medicine is developed. So you don't just go out and say, would you like to try this pill? Let me see if you will die or not. You will start sort of from the lab and test, go out after a while, and then you might have to go back to the lab. And I really feel that that's very true about the development of driverless cars, self-driving cars, whatever you want to call them. I just want to quickly come back to this cultural differences in inverted commas. I feel it's this intention recognition of pedestrians, whether or not they want to cross, etc., is something perhaps that's missing right now. So I don't know, I'd be very happy to hear more. And I was very impressed with the Waymo ride a couple of years ago. I've heard very good things about the Wave ride as well. There's definitely the ability not to hit, which is great. But whether or not there is more than that in terms of how we as drivers can tell if someone's going to jump in the road or not way before, I'm not sure if it's there. And I think the other thing that's really interesting is this sort of behavioral adaptation that we see. So I always give the example of a very long time ago. Again, I think it was in Vegas. I don't think the company's even going anymore, but they were sort of doing a demo of this driverless car, and there was a guy on the side of the road looking at his phone, absolutely not intending to cross, and the car just would not go forward. In the end, the guy had to go back to allow the car to go forward. And that was a really clear demonstration of we as human beings are helping, in a way, the sort of these new guys on the block, and there's lots of more guys than girls, to sort of really let them in and let them sort of integrate in society. But it is an interaction. It has to be an interaction and a mutual understanding. And I think that's probably an area where one of the areas that there is a lot more work to be done yet.
Yeah, and Bex, I'm sure that you can add to that.
Yeah, absolutely. There's a few things. I'll try and come back to them in the right order. I actually wanted to go back a few bits to the sort of trust aspect, but this ties into the point that Natasha was saying about the sort of ecosystem and the loop and the need to kind of continuously go back and test things. But it touches to the point that Trent was saying about the continuous improvement. I think what we know from user research and user engagement is that it touches on the point of explainability as well, that actually the general public know that it's not a new technology in that it's, you know, a couple of years old, but it is new in terms of its sort of widespread deployment on public roads and kind of that interaction aspect with it. And so what we found was actually demonstrating to the public the amount of work that had gone in, and the going back to the testing, the going back to continuous improvement, the explainability aspect was actually really, really critical to public trust, because it demonstrated that the system was learning and continuously improving. And it was a recognition that there was no one trying to pretend that it was perfect and that the product was ready. And I think often we have a narrative around autonomy, which is we try and we hype it up. That's, you know, it's an exciting technology, that's what we do. That comes with a misconception that it is ready and that it's just ready to go and that it can manage anything. And so it kind of comes back to the point we're talking about, those expectations. If we, for lack of a better term, turn it down a little bit in terms of actually the fact that it is a technology that is being developed, that many of these environments are trials where the data is continuously being fed back in to enable that learning and that development and that improvement. That's something that is really, really critical to public trust, because it demonstrates that their feedback, their engagement is feeding into the system. And it kind of goes back to the point around explainability, which is that we talk a lot about explainability in terms of being able to explain why the technology did something. And I think I saw Nick on the webinar. He's been talking a lot about digital community driving over the years. Now, explainability, from my perspective, has two aspects here. One, which is trust and safety when you're in the vehicle, especially if we look at it from sort of diverse user group, which is many individuals can't necessarily rely on the same sources of information or cues when they are in the vehicle. Therefore, it's really important to make sure if there is a change, if there is an emergency, Claire, you'll know this very well, if there's an emergency, but also if there is a change in the behavior of the vehicle that is unexpected, to be able to explain that to ensure that that trust isn't lost and that comfort and confidence is still there. We've seen that from research beforehand, that when you can explain what's happened, that uncertainty goes away. It just sort of like, you see peaks and changes in cognitive response, and then it comes back when that explainability is there. But the second aspect that I think is really, really interesting is in that continuous feedback loop, which is if you can explain why the vehicle behaved the way that it did, you can look at why it behaved that way and then how you would change it. And that is also really important from the perception of public trust, because it goes to show that in the event of something happening, there is due diligence that can be done, and it can be understood, and it can be improved. So we talk a lot about explainability from a regulatory perspective, but actually it has a really important role to play as well in that public trust and that confidence, and to the points we've been talking about, cultural differences as well.
Perfect. And Saber, I think you've got something to add as well. We'll come to you next.
Yeah, sure. I would like Ignacio briefly comment on it. I'm a little conscious of time, so we need to be careful. Ignacio, could you please go ahead?
Yeah, I was just gonna say that Becca makes a really, really good point on expectations of the technology being done, and I think that there's a very long tail of use cases where we expect the automation to perform. The reality is that as we deploy in more and more complex scenarios, we're expanding the operational design domain of these systems. Transparency becomes very, very crucial, right? And we have to do it in a proper way, and we have to do it in a way that not only technology is capable of doing that and explaining it, but also that people can understand the limitations of the technology and be prepared to cope with those. That's extremely important as well. And the fact that we're getting into embodied AI with the capability to really have that action, and actions that are even to a level that is equal, or in some cases even above what humans can do, humans that are paying attention, not only humans that are not paying attention. This becomes a very, very important crucial role that we have to do, is educating society as well on the limitations of the technology, and bringing them into helping us making those technologies more accessible, helping those technologies learn, so that we can all benefit from it.
Okay, great. I would like to ask two follow-up questions based on the discussion. It's a very interesting discussion. If we wanted to talk about this stuff, it's going to take forever, to be honest, to discuss about these things. Very interesting and very important topic to discuss, to be honest, to build the trust on this technology. But what is common between what Natasha mentioned about non-verbal communications between the humans when they're driving the car or when interacting to each other on road, or when interacting with vulnerable road users, or when we have the different cultures? The reason is that we can't, as a human, we have different levels of the cognitive abilities or capabilities. And we know that AI is going to be brain behind the self-driving car, so we cannot deny that one. And now the question is that, do we have the AI to be enough intelligent as a human to drive the cars the same way that the human do? Do we have or do we not? To me, because my research is about safe AI and I'm really interested in these things, I was wondering, do we need to build up this capability to self-driving cars? At the moment, this AI is, as Daniel said, is data-driven. If we want to make it cultural awareness, if we want to make them to work, interact with the vulnerable users, or give them some sort of the non-verbal communication capabilities, is data-driven approach or collecting the huge amount of the data, is it feasible, is practical? I know that, for example, Waymo has driven their cars millions of miles to collect the data. Is the statistical analysis or the statistical data enough for the AI? I'm not talking about just from the regulatory perspective. I'm not talking about it just from as manufacturer, even from the research side as well. So I would like to know hear from Trent. He raised his hands. Yeah, go ahead, Trent, please.
So you have two aspects to your question. One aspect is comparison with human. And I think with comparison with human, this is a really exciting modeling that's been going on. So driver modeling, and this is also Leeds that we're very involved with working together with. There's been some really major advancements in understanding how to model human behavior. So active inference is a whole paradigm that's coming in, and it explains the way humans interact in motion and understanding cues. So it's all this stuff we've been talking about before, which is the naturalness of our behavior and how it's grounded in the sensory motor control. And that is what's being seeing a lot of advancement. So using that model or an understanding of human behavior and navigation of human behavior as a reference is really important. So the reference we're using is a non-impaired, eyes-on conflict driver, and we compare our driving compared to that model, and that model itself is being developed over time. So this question of like what a human would have done in comparison with it's compared with the model. But the second part of your question is, do we have enough data? And I would say that we have the most data that ever has been amassed in traffic safety. So the amount of driving we've been doing with the cameras and all the logs that we have, there's been major projects, but the millions and millions or hundreds of millions of miles that we have, it represents enough data to compare. Yes, I would argue that.
Okay, good to know. Daniel, go ahead, please.
Yeah, I mean, just quickly give a regulatory perspective. I mean, probably most people are familiar with where the UK landed in terms of setting a safety standard. So obviously it's quite commonly used at the international level as well, this idea of a careful and competent human driver. So, demonstrating performance at least as equivalent to, if not better than. I think it's always really important to remember also the average human driver is not a careful and competent human driver. So, the standard we all need to reach in industry is absolutely the highest standard we can. And I think that's why everyone in the industry is behind this technology, because, the ability to add 360-degree sensors and intelligent decision-making, that means that actually reaction times and blind spots and the ability to just interact in a way that a human can't really does shift the dial on that. But, ultimately also we need systems that can be more intuitive and adapt and respond to the real world, and that that ultimately I think is the data-driven benefit, right? Because you can start to train from advanced drivers, you can start to see some of those nuances in interactions that programming or hand coding would never be able to achieve. And that's the beauty of the paradigm shift we're seeing in industry towards embodied AI, because we're going to have these more intuitive models.
Perfect. Thank you very much, Dan. Perfect,
we
Daniel.
need to move to some of the questions, and just we are conscious of time.
I'm a little question.
Yeah, we've kept an eye on the questions in the chat, and so we have shaped some of this discussion around the themes that people have been asking about. But there's one that really hasn't had much direct conversation about, a question that we have here from Cormac Mackay, who says that he worries that although there is this advanced potential for embodied AI, it's that actually many people, certainly in the first instances, it will be a premium service that not many people can afford. So how important do all of the people involved on the call, how important is it going to be to make sure that it's not just some users who are having the experience and we're basing our data and validation models on the people who are actually using it? Perhaps who would like to go first? Whoever gets their hand up first. You can actually use your physical hand if you want.
I was going to put the physical hand. Short answer, it's absolutely essential. I think if we're going to look at the longevity of autonomy, and autonomy is more than just one use case, it's integral to the success. And when we look at public perceptions, the majority of people, the use cases that they want to see the integration of automation within, it's public transport and it's shared mobility. So yeah, absolutely essential that we don't just stick with the early adopters.
Perfect. And Ignacio, your take on that?
Yeah, it's a very complex question, but one that is very fair. And the reality is that is complex is because if you think of the technology, even if it can be developed, doesn't mean that it's cheap enough that everybody can benefit from it, right? And so you have to face the realities of how do you make this technology as cheap as possible. That way everybody can adopt it and the masses can adopt it. And that is complex. That requires both a regulatory framework to operate. It requires an incentive for companies to really put everything, all the skin on the game, and it requires all the research that we're doing in order to bring the technology to that point. So it's very complex, and the real complexity is how do we do it in today's world, but not can it be done. I think all of us here in this panel are
orientated. Yeah. And Daniel, you starting to really do it, in spring. What can you tell us then about your user and how you're going to bring more people in?
Yeah, I mean, obviously, a lot of this is possible thanks to what the UK government has been implementing through the Act. So we announced our intention to take the next step, because obviously we've been testing in London now since 2018. So, we regularly, drive around and test with safety operators in London. It would be great to work with a mobility platform like Uber. We announced to turn this into trials. Obviously, we're still kind of working through the detail, but I think the key thing is there's many complex pieces of the puzzle still to come together as we see the implementation of the Act. So we're really kind of keen to keep working with CCAV on making that possible. And I was just going to quickly say, I think ultimately it comes back to the point that's been raised before as well, that this isn't going to happen overnight. So that progression towards accessible, inclusive deployment comes with gradual testing, deployment, scaling up. But ultimately, we need scalable solutions to make the cost effective.
See, well, we are conscious of time. So anybody who has asked a question in the chat, we are going to have a follow-up survey to really interact with what you enjoyed about today and what you'd like more of in future webinar series. And so those questions we'll ask our panel to add some comments to that, so you still feel that you've had the opportunity for them to be answered. It just leaves for me and Saber to say thank you so much to our fantastic panel. We really have appreciated the effort and you've put in into preparing for this and for also being really engaged and considering each other's points of view. So thank you so much. And yes, we will be looking forward to the next. We've got lots of emojis, obviously, because people they've not been allowed to do the chat. So now they're just going crazy because they've discovered I left emojis on. So well done, everybody. Do it, feel it, send the love. Thank you so much, everyone. Have a wonderful afternoon, and thank you very much. Bye-bye.
Thank you very much. Bye.